great way to localize bugs to a tiny part of your program is incremental development. That means you're building only a little bit of your program at a time and testing that bit thoroughly before you move on. Because that way, when you discover a bug, it's very likely to be in the part that you just wrote rather than anywhere in the huge pile of code that you might have written. So our class on testing talked about two techniques that really help with incremental debugging. One is unit testing. When you test a module in isolation, you can be confident that any bug you find is in that unit, or maybe in the test cases themselves, but it's a smaller amount of code. Another is regression testing. When you're adding a new feature to a big system, run the regression test suite as often as you can. If a test fails, the bug is probably in the code you just changed very recently. You can also localize bugs by better software design. So there's sort of two key principles here. One is modularity. That means dividing a system up into small components or modules, each of which can be designed, implemented, tested, and reasoned about and reused separately from the rest of the system. The opposite of a modular system is a monolithic system. So think about, for example, writing all of your code in a single giant function. That's big, it's got all of its pieces tangled up and dependent on each other, and there's no way to individually separate and test small pieces of that giant function. So you should really aim to break your programs up into much smaller pieces, small functions and classes. That will make it more modular. The second key idea here, which is related to modularity, is once you have modules, you can encapsulate them. So that means you can build walls around them, and that's where the name comes from. Think of it like a hard shell or a capsule, so that the module is responsible for its own internal behavior, and other parts of the system can't threaten its integrity, can't threaten what's inside that module. So languages like Java give you access control, keywords like public and private and protected, that let you control the visibility and accessibility of variables and methods in a module. A public variable or method can be accessed by any code, but a private variable or method can only be accessed by code in the same class, so that's inside the capsule. Keeping things private as much as possible, especially variables, limits the code that could inadvertently cause bugs. It means if that variable value, if a private variable's value is wrong, then you should look for the bug just inside this class. Can't be caused by somewhere else. Now another kind of encapsulation, so that's encapsulation with respect to modules, but variable scope is another kind. So the scope of a variable is the part of the program text over which that variable is defined, in the sense that expressions and statements can refer to it, can read and write it. The scope of a method parameter is the body of that method. Right? It can only have meaning within inside the body of that method. In Java, a local variable's scope runs from its declaration to the next closing curly brace. Past that curly brace, that variable no longer has meaning. In fact, Java will give you a compile error if you try to use that variable. Keeping variable scopes as small as possible is a very important principle of encapsulation, because it makes it easier to reason about where a bug might be in the program. If the variable value is wrong, the only place it could have been screwed up is somewhere in that scope. So if its scope is small, you have a lot less code that you have to study in order to find the error. So for example, suppose you have a loop like this that starts an integer variable I at 0, runs until it reaches 100, and increments it each time around the loop. And inside that loop, you're doing a number of things, but you're also calling this method do some things. And now you discover you have a bug where this loop is running forever. So I never actually reaches 100, even though it looks like we're incrementing it each time. So somewhere, somebody else is changing I. It's not just this part of the loop that is changing I. The question is where? Now, if I were declared as a global variable, we've talked about global variables in the previous reading. Global variables are public. They can be accessed from anywhere, and static means that there's only one instance of this variable. But the problem with a public static variable with a global variable is that its scope is the entire program. It can be changed anywhere in your program, not just inside this loop, but somewhere else in this file or in a completely different file. But if I is instead declared as a local variable with a narrow scope like this, in particular notice the difference here is that we have actually made this into a declaration of I instead of just an assignment of I by putting the type here. This declaration of I means that now I is a local variable whose scope runs until the next closing curly brace, the matching closing curly brace I should say. So the only place where I could possibly be changed is inside this for statement. In fact, only in these places, these ... bits of code that I've omitted. Could it be in the body of the do some things method? No, because that's implemented somewhere else in this code that is not in the scope of this variable. So it can't actually change I. It can't access or change this local variable. So that substantially reduces the risk that we are accidentally changing this variable in the wrong place. Minimizing the scope of variables is a very powerful practice for bug localization. So here is a couple of rules that are useful for Java for minimizing the scope of variables. One is you should always declare a loop variable. When you're writing a for loop, you should declare the loop variable in the for loop's initializer. So rather than declaring I somewhere above the loop, which means that its scope will include the loop as well as some code after the loop, you should instead declare it right there at the beginning so that its scope is limited to just the for loop, just the body of the for loop. Another rule is declaring a variable only when you first need it, and this is related to the for loop rule, and then push it down inside the innermost curly brace block that you can. Don't declare all of your variables at the start of the function. It makes their scopes unnecessarily large. Declare them as soon as you start needing them and in the innermost curly brace block that you can get away with. Now I should note here there's a difference between Java and other languages like Python and JavaScript. In many of those languages that don't have static type declarations, the scope of the variable is normally the entire function anyway, so you can't restrict the scope of the variable using curly braces in this way. And the third principle is just avoid global variables entirely. They're a very bad idea, especially as programs get large, because when you have a bug that involves a global variable, you now have to search the entire program to figure out what part of the program might have caused that bug. Global variables are often unwisely used as a shortcut to provide a parameter to several parts of your program, but it's a much better idea just to pass that parameter into the code that needs it, rather than putting it in the global space where it is at risk of being inadvertently reassigned.